Okay, what's a simpler form? You could do this multiple ways. You could actually, you could do a grid pattern if you want, like a table, and maybe I'll do that for number 27. For number 26, though, I just want to show you really what you're trying to do is say, I need every term in the first polynomial in parentheses to be multiplied by each term in the second one. So, for example, if I was to use the kind of foily looking thing, you would say this times this, that times that. Then you would do this times this, and this times that. And then finally you would do that times that, and that times that. Okay? So let's do it. Let's do that. Let me erase those marks. And let's just write it out. We'll eventually have to combine the terms, but so I'm going to start with this one. I'm going to start with, and I'll do these maybe in separate colors. I'm going to start with this. 2n squared times 4n is 8n cubed. And then I'm going to do 2n squared times negative 5. Notice that I'm multiplying it by both of the terms in the second polynomial. Okay? So 2n squared times negative 5, negative 10n squared. And then I'm going to do this times those two. 5n times 4n, 20n squared. And then 5n times negative 5, negative 25n. And then finally, I'm going to do this positive 3. Positive 3 times 4n is positive 12n. And then positive 3 times negative 5 is negative 15. Okay? Ultimately, then what we're trying to do is we're trying to say, what can we combine? So I see just the single n cubed term here. I don't see any other n cubed terms. So I'm just going to say 8n cubed. Now, for the n squared terms, I see an n squared term here and an n squared term here. So I got to combine their, add together their coefficients, negative 10 plus 20. Negative 10 plus 20 is positive 10 n squared. And then I see these n terms, negative 25n, and this n term, positive 12n. Negative 25 plus 12 is negative 13n. And then the last thing I see is the constant term here, negative 15. And there's nothing to combine that with, so we just says negative 15. Okay? And where do we see that answer? 8n cubed plus 10n squared minus 13n minus 15. That is A. Okay. That's one way you could do it. I'm also now, I'm going to do a table for you so you can just see it. So just give me a second while I draw out the table. Okay. So here's the table. And basically what you're going to do is you're going to take this first polynomial, this right here, and you're going to write the two terms like this. You're going to say 4k and 5. It's positive 5, but as long as we just write 5, we know that it's not negative. So, okay. And then we're going to take the other, this right here, and we're going to write that in each of the spots. 3k squared, negative 4k, and negative 4. And what that's going to do is then it's going to give us a grid pattern where we multiply everything in the first polynomial by everything in the second one, right? This is 4k times 3k squared, 4k times negative 4k, and 4k times negative 4. And then this is 5 times 3k squared, this is 5 times negative 4k, and this is 5 times negative 4. So let's write them in. What do we get? Well, what we get is 12k cubed. Here we've got negative 16k squared. Here we've got negative 16k. And then for this line, for 5, we've got 15k squared, negative 20k, and negative 20. And then what we're looking for is what can we combine? And you'll notice that these two terms here are both x squared terms, and they can be combined. And these two terms here are k terms, and they can be combined. So let's write out what you get as a result. Well, first we've got the k cubed term that doesn't get combined with anything else. So we've got 12k cubed. Now the k squared terms combined, 15 minus 16 is negative 1, or we just put negative k squared. And then these k terms, negative 20k and negative 16k, become negative 36k. And just to be clear, that right there is a negative right there. Okay. And then nothing, just the one constant, so nothing combined with that. And that's what you get. So then we're looking for our answer. We've got 12k cubed minus k squared minus 36k minus 20, and that is answer A. So you can do it either way. You can kind of like FOIL-ish. It's not really FOIL because it's not two binomials, but you can kind of do this times that, that 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 times that. Or you can write it as a table or whatever method you prefer. But I just wanted to show you both ways so you can choose your favorite.